All right, welcome back everyone. In this video, what I want to talk about is a .NET downloader that I came across the other day. I don't particularly know the family or recognize the downloader itself, but it presented a number of interesting aspects. And since I took the time to analyze it, I figured I'd go ahead and share it here. To get started, what caught my eye, here you can see hashes, and again, I'm just making sure I capture this. I guess MD5 is complete. This one's a little cut off because of the zooming. Just wanted to make sure I capture this. I'll post this hash value in the video description as well. If you look down at the process activity, so there was one thing that caught my eye that led to another thing that I became very interested in. The first is we have this, our original executable here that executes PowerShell, and then we have the Windows Event Manager. And I notice with the PowerShell execution, looking down at the network activity, that it was responsible, not a big surprise, for retrieving what appears to be the next stage. And why this caught my eye was that there was no arguments. While I can't say with absolute confidence that PowerShell will never be executed without some arguments, it really seemed odd to me. So I wanted to figure out what was going on there. In addition, the URL, if you look at the that particular URL and remove the text file resource, there is a lot of payloads here. All of them are very recent, again, relative to the time of this recording. So, I figured if I could understand what was happening with these TXT files, then perhaps get a bunch of files to decrypt or decode or whatever's going on here, and figure out what this directory is full of and what it's delivering. Now, in order to understand that, of course, one of the first things you could do is you could just go ahead and download all of those payloads, and of course, that's what I did. In looking at this content, though, and hopefully the font here isn't too bad. There's always issues with, it seems like whenever I record, getting this resolution to come out nice. That looks a little bit better. You can see by looking at it that this is base 64. And if you're not familiar enough with that, it's really the sequence of characters. It's uppercase, upper and lowercase, alphabetic, numeric, and just a handful of special characters. So usually this sequence of characters gives it away. Sometimes and oftentimes these are padded with equal signs, 1, 2, or 3. That doesn't happen to be the case there. So we could just take that, all of those different text files, we could download them. We could go to CyberChef, as I've done here, upload the file as the input, and then just do a from base 64 and see what we get. Of course, if we get lucky, then we'll just have a decoded executable file. We would have seen a PE file or something here that's being executed, but that's not the case. You see there's more randomish looking characters. We might, if you do, let's see, file, detect file type, sometimes this will reveal a pattern that's actually a gzip file or something, but in this case, it says that it's unknown. So it looks like, at least the way that I approached it, if I can figure out what that .NET downloader is doing, then I can figure out likely what's going on here. So with that file being .NET, that means that it is a good candidate for dnSpy. And if you're not keeping track, dnSpy has long been one of the go-to tools for reversing .NET malware, or I guess .NET binaries in general. But that project was it just was no longer maintained. So there is a fork of it, dnSpyEx, that has been maintained. And again, as of the time of the recording, a lot of releases recently. So I always grab the most recent version from that GitHub before I start these recordings. I've had a previous videos on dnSpy and working with .NET binary. So if you're interested in a little bit more about the getting started aspect of that, you can go back and take a look at that. So I'm going to work with two different samples here. So here's the original text file just downloaded. We looked at that just a minute ago in hxd, the hex editor. But I have the original sample, and then I have this clean version. Now, what you'll notice when we drop this into dnSpy and we expand it, one of the first signs of at least some form of obfuscation, and you could almost anticipate there being many, is the use of the Unicode characters in the class and the property and the function naming convention. So that can just get hard to recognize or keep track of what methods that you're looking at. In order to help with that, and I won't go through it here because I've used this tool in many different videos and it's really fairly straightforward, is to use de4dot. Again, it's another project, it's not maintained, but it still can help with obfuscation such as this. And I'll drop this cleaned version. So I just used de4dot. It's available in Remnix. You run it against the binary that you want to clean, and then it'll spit out a cleaned version if it's able to help. You'll see that it does some renaming of those classes and some of the properties. So helpful just in the sense that I think it's a little bit easier to recognize where you are at when investigating this particular binary. Now, in addition to, you'll see it's not responding. That's, I would say, another part of the anti-analysis here is that we're dealing with some very large methods with a lot of arguments, and it's just really giving the tool some fits here. So when I typically run into this, and I don't run into it too often, but when I do, one of the things that I will do just to help is to take the project, and I'm just going to condense those. I guess it doesn't matter. But if we just select the project, you can do a file export to project, and then select your folder. So wherever you'd like to extract this or export this project. And then once you've done that, all you have to do then is click export once you've selected that folder. Once you've done that, you essentially get kind of a project structure. I think I've never actually done it, taken it into Visual Studio, but I think it's meant to, at least there's a potential that you could take it to Visual Studio and try to build it and stuff. I haven't actually tried it, so I don't know if that's even supposed to be a path, let alone how likely it is that it'll work, but it's something to explore, maybe a future video. So now I can use Visual Studio Code, and I just find that for when I'm trying to initially navigate the code, and I don't really need all of the, I don't need to set breakpoints, I don't need to quickly navigate around the binary, that just doing some raw searching, as you'll see here in a moment, that Visual Studio can sometimes work really well because I just get really impatient. So now with this one, let's go back. This is the clean version. Again, you'll be able to recognize that just because we don't have any of those Unicode characters in any of the classes or properties or methods. We can right click and go to entry point. And so in addition to just the size of these kind of slowing things down, when you look at the entry point, you'll be able to kind of immediately recognize that one of the another primary form of obfuscation here is the use of code flattening. So code flattening, we have a for loop or some sort of a looping structure, a switch with a num or a variable that's being updated in each case, and then within the case, it's either going to have some important logic, like a function call or whatever, as well as then oftentimes either a go-to or something that will go to another case. Let's see, I can find that there, which then something that will calculate that num variable that's used in the switch so that it can go to the next state. And so it just breaks up the flow here. This particular switch isn't terribly difficult because you can see, well, really the only thing that's important is this method right here. But as you dig further into this binary, you'll see it just happens over and over and over again, and it gets really tedious. So in order to not deal with that, at least not right now, I'm going to use the Visual Studio, and I'm just going to do a little bit of searching. So one of the first things that I started for, you saw the results there for just a moment. That's sort of the end state. So we're going to back up and start here. Is that I know a process is going to be created. I know PowerShell is going to be launched. So we have to have somewhere in this project, somewhere in this code, the ability to, the code has to create the process and launch it. Now, just searching for process, you get quite a few results. However, most of these matches are in, arguments to a function. And so skipping ahead a little bit, you'll start to recognize, okay, here are some more, key statements. And we'll come back to those in just a minute. But if I scroll down a little bit further, you'll see here's the creation of that process. So we can select that, and that will open up the file, the C# file in this case, that it was located in, navigate us to that location. We can back up a little bit. We could identify the method. So now if I wanted to, I could go back to dnSpy and I think rather easily set a breakpoint. And we can see that the process is being created and it's being assigned to process_0. So what we can do with that then is search on process 0, and one of the results that you'll find is there's a couple of things here. One is we have the start info. So process0.startInfo equals this other start info object. Start info is going to be the structure that provides the command line and all the other information necessary for the process to know what to load and how it should start. So we can select that, and again, we have a location. So I'm probably going to start setting breakpoints here just so we can sort of step through it. Now, if this is in fact the code that's going to launch PowerShell, then I also want to think about it. I start thinking about it chronologically. I'm going to have a process object instantiated. Then something like this has to come along and tell the process about what it should launch and how it should launch. So this should be up there early in the process. And then there'll be things like well, you'll see in a minute what other aspects or elements here that we're going to uncover. So what I'll do now is I will go look for smethod 223 in gform0. So there's our gform0 class. And again, because of the the obfuscation here, things get a little bit slow. So you'll probably see as things don't respond, I will just pause the video and we'll pick up once things are back to normal. Okay, I did have to make, so I did pause the video. I had to make one adjustment. I unloaded both of those projects, those assemblies, in just the clean version. Hopefully that helps a little bit. But you can see eventually here we got to smethod 223. And just scrolling down a little bit, here's the start info object being assigned, or the start info property being assigned that start info object. So set a breakpoint, and now I'm going to go back to Visual Studio Code to help with the sort of further exploration here. If we scroll up, we also have the process 0 start. So that's another sort of indication that this is the right object to trace. And it doesn't always, or at least for me, it doesn't always immediately jump out. Sometimes I have to do a little bit of searching and looking in order to understand which is the most important one. Very similar to the previous, we could go to smethod 115 in gform0, and we can set a breakpoint there in order to catch the start. And the reason I might do that is just so that the next stage doesn't execute. Here, it's just simply going to try to execute some PowerShell and download a payload. This VM's not connected to the internet, so no big deal there. But it does sort of catch that from going too far, and so I don't mind setting that, because then that way, if I know that gets hit, I might have missed the more important breakpoints, or might have misunderstood something, or maybe there's multiple paths to get here. And so it's just, again, sort of a sanity check. So there we go. There's our start. And now I will set that breakpoint. So now from there, you'll also find there is a pretty important statement here. And that is this stream writer standard input equals process_0.standard input. And this is actually the key as to why the PowerShell command didn't have arguments. Oftentimes you'll see the dash encoding argument with a base64 encoded script to have the commands that it's going to execute. But what's happening here is essentially standard input for this process is being remapped to this stream writer object. So this is definitely important. And instead of setting a breakpoint here, because I don't really need to see the assignment, what I can do, or what you could do, is search for just standard input. And let's see what we get. Here we can see, all right, so a couple of things. Here's that process start info. I said it's an important object structure in terms of starting the process, telling it how to start. Well, here's one of those aspects. It redirects standard input. And I didn't dig any further into this, but this would imply to me that there is some sort of a configuration, or there properties that when this downloader is built, it's an option for whoever's creating it. So it could redirect standard input, it could not. this also, if we continue, like let's say we were really interested in figuring out how to unravel strings. Well, we're probably going to have two good opportunities to do that. One is with the process start info, the command line. What is that? And where is that string coming from? And the one that I'm going to focus in on is the use of this stream writer. So knowing that we have a stream writer, I did a little bit of research, and stream writers have a write line method. And here you can see, very similar to the previous process object, it's actually streamwriter _0, and then here's a dot write line. String 6 is the argument, so this could be another opportunity if we really wanted to figure out where all these strings are stored, to trace back and figure out where did it come from, at least to this method, and then go back further to figure out where it was decoded or decrypted. Again, I didn't do that because now what we can do is we can set a breakpoint on s method 7 where these write line methods or write line calls are being made. So let me just refresh my memory. S method 7. Okay, and the order here is not necessarily as you might expect. So we have to scroll down all the way to the 7. So again, just gonna take a couple minutes. So I'll probably pause the video. Okay, and there we go. There's S method 7, and there's our streamwriter 0.writeLine. So the idea behind it now is that because that process is going to redirect standard in to the streamwriter object, anytime data is written to the streamwriter object, that's passed to standard in to our PowerShell process, and therefore it executes those commands. So that's why we didn't see any arguments when we looked at that behavioral analysis here in triage. So I've never come across this. I thought this was quite clever, and so that was interesting, and kind of worth that exploration in my mind alone. Now, what about those payloads? Well, now we are ready with our breakpoint set to go ahead and just run the debugger. So 9 times out of 10, if all I care about is seeing decoded, decrypted strings, I'll just run it in a debugger. So find that point where it's going to be decrypted or decoded. It has to be here in order to be a valid PowerShell. Oops, don't want to click on that. To be a valid PowerShell. That doesn't mean that the PowerShell won't be encoded or obfuscated, but at least we'll have the next stage. So I'm going to go ahead and click Start. I don't need to break. I just need this to begin execution. Again, because of all of the... Okay, so here you can see our first breakpoint has, it's been encountered. The start info object is being assigned to... oh, shoot, I always forget. Be careful what you click on. Not that that causes any harm, but just that it's easy to do. And so we could inspect the object by expanding it. You can see things like file name, which at this point is really no surprise. It's loading PowerShell, kind of already knew that. But other properties here that could be relevant to an investigation. Also, we have just other variables that they're going to be present, depending on where we stop in execution. So we can see string 2 is also the PowerShell path. So likely that was the string used in order to create that, populate that member of that object. Okay, so that's just more or less to confirm. Now we can see that the start is actually encountered first. So my expectation earlier that this would come, at the very end is actually wrong. It actually it happens now. And then the redirection, the writing of the input to standard in occurs. So that's good to know, all right? And sometimes certainly my theories I'm proven wrong on a daily basis, but we have the ability to experiment, test, and learn. So we're going to go ahead and continue. Now we've gotten to the right line, and this is where I want to investigate string 6. So now it's just a matter of going down the locals window. There is a string 4. Interesting, certainly some PowerShell, but the string 6, as you can see here, that's what's going to be written to standard in. Now this looks like it's commented out, start sleep seconds 30. So again, speculation at this point, maybe it's part of the configuration, an initial delay before it runs the PowerShell. Maybe it's just how it's been coded. I don't know. But that doesn't look like all of our commands, right? That's certainly not enough PowerShell to download that next stage. So if we continue again, now we have another break at that instruction. and we can see, okay, here is $ARR1 equals, and it's another statement. Let me see. If we go up to string 4, you'll notice that this is in fact a very large PowerShell script. And so what it appears to be doing, let's see if we run it again. String 6, you can see payload var. So let's take that string 4 value that we discovered and let's paste it in, toggle the word wrap. Okay, so I'll replace semicolons in order to, this doesn't look like it's, there we go. Replace semicolons with new lines just to get a better visibility here. And then we don't actually need the carriage return line feeds either. So I guess let's just, for the sake of completeness, get rid of those as well. Carriage return line feed, no regex, and replace those with nothing. Let's see what happens. Okay, that looks good. So it appears that it's looping through more or less one statement at a time, writing it to that stream buffer, but it's pulling from a source string, and now we have all that we need. We can see quite clearly that here is the URL that we've been searching for. There is that text document, and from here it's just a matter of analyzing the PowerShell. So the quick version of that is that gets stored in this variable. That variable then does get base 64 encoded. We already knew that. But now the key to the next stage is, we have AES, right? So it's instantiating an AES object using CBC mode, and the key and the IV are both base 64 encoded as well. So there's the key, there's the IV. It then looks like it does the decryption before, or it does the decryption before it then, let's see, so we've got our payload var. You'll have to forgive me, I'm not super familiar, at least I don't have the immediate details of AES off the top of my head, but I don't need to look them up because, again, we just sort of figure this out. This must create a decryptor variable, and then this must do the decryption into this payload var, because then this is finally decompressed using gzip, right? And then finally it's loaded using the system.reflection, and the entry point is invoked. So with this information, we can now just go ahead. I'm going to copy both the key and then the IV. And what we can do is go back to our CyberChef. So now we can do AES decrypt. There's our key, and that is base 64. Let's get our initialization vector. Same thing. Oh, I don't know where that just went, so I guess we'll try that again. I must have double-clicked somehow. Okay, so we'll just copy that again. And what we're looking for, CBC input is raw, and output will be raw as well. So what we're looking for is content. We know that it's not going to be sensical yet because it's still gzipped, but we don't get any decryption errors. We don't see any error messages here in the lower right hand. So now what we can do is, I believe there is a gzip. Yep, let's try gunzip. And there we go. There's our PE file. Okay, now what we can do is generate a hash just to keep things, I think, a little bit smaller, and because I have everything zoomed in, I'm just going to grab the MD5. So there that is. And if we look for this on VirusTotal, you'll see that it has been uploaded about a month ago. We could do the same on Triage, but I don't think it's been uploaded here, so that would be something that we could do. Depends on where you want to have your further analysis done. Okay, so fast forward a few minutes, and here you can see the results are in on Triage. They have identified this as cryptbot. So an interesting find, which means that there's lots of other very interesting things in this directory. Unfortunately, I did take a look at the other text files and I tried to decrypt with the AES key and IV that we just discovered, but it doesn't work. So they are using different keys for different payloads, unfortunately, unfortunately for us. So anyways, just wanted to, again, provide some insight there into that analysis and the .NET downloader that was very, very obfuscated. But those are some techniques I use to try to unravel that in a quick fashion, at least as quick as I can, so that I can get to the parts that interested me. That is, how did that PowerShell not, how was it executing commands, and what was happening to those payloads on that open directory? So if you have any questions, comments, suggestions, please drop them in the comments section. Otherwise, hope you enjoyed the video, and I'll talk to you all in the next one.